properties on this one. The first one I'm gonna look at, they deal with 1 through 3. And they say if you have some x to the a equal to some x to the b, then a is equal to b. That's the property. If this is true, then that's true. So your goal is to make the left and right hand side have the same base. You want same base on both sides. So I taught you guys to do the easy stuff first. Divide that 36 out. If you divide that 36 out, obviously you got a cancellation on the left. What's 4 over 36 reduced to? 1/9. So 1/3 of the x over 5 is 1 over 9. Now these are both powers of 3. How can I rewrite 1/3 using negative exponents? Think about that. You got 1 over 3 to the first. What happens if you shift position? The 3 moves up top. What happens to the 1? 3 to the negative first. So I'm going to rewrite this piece as 3 to the negative first. You already have an x over 5 up top. You just stick those exponents with each other. You can put the 1 there if you want, but it's understood. The other side, does everybody know that 9 is 3 squared? So 1 over 3 squared becomes 3 to what power? Negative 7. Now we've achieved this property. The bases match. What's true about the exponential space? They have to be equal. Have no choice but to be equal. So negative x over 5 is a negative 2. I'm just going to go ahead and make those both positive since we divide that out anyways. And what do you multiply both sides of? 5. Opposite division is multiplication. That'll give me x is 10. So I will let you guys work on 2 and 3 on your own time. I'm going to jump down to number 10. 10 is log is bay. A logarithm base b argument a equal to some e is equivalent to what? What's the b stand for?
Base.
Base. What's e stand for? And then a here is literally the answer or the argument. So just go through and identify your pieces. Base argument exponent. So base is going to be 4. What's it going to get raised to? First. 1 minus x. 4 to the first is 4. 1 minus 4 is 3. Divide out your negativity. And x is a negative 3. Now, you do also need to remember as you're doing these things that if you have a logarithm, its argument must be what? So if I plug that negative 3 in, is the logarithm going to be happy?
Yes.
Why is the logarithm going to be happy?
1 minus 1 plus 3 is 4.
1 plus 3 is 4. We've got a positive number. I would say on a given test, standardized test, if there's an extraneous answer, it's in this way, over 80% of the operation. Easy. Alright, here we have more. Solve each algebraically. Obtain a numerical approximation. Not worried about that. Don't care what the number is. So they're not bad. They're the other way around. These are exponentials. What we were doing previously was called exponentiating. You took a logarithm, turned it into an exponent. This is the other way around. Exponents to logarithms. I know this is my base because what does it have? An exponent. That means this guy would be my argument. So I'm going to write a logarithm And what's that logarithm's base gonna be? 1.06.
Oh, wait, it's pursuit.
What would its argument be?
4.1.
4.1. What would it have to equal?
X.
X. That is a really ugly looking answer. There's two ways to get this to where you can push buttons in the calculator. One of them is change your base. Logarithm base for the argument A is the natural log of something over the natural log of something. Remember, what's high stays high, and what's low stays
Low.
low. So the argument up top, the base in the bottom. And it is preferred that you give your answer in that form. So I'd have the natural log of something up top over the natural log of something down low. We can't use Parker-Scott's technique because that button doesn't exist on T84. So what goes up high? 4.1, and what goes down low?
1.07.
And then you could push buttons in the calculator. Now, we could have done this problem a way different way and saved ourselves change of base. Or you can ln both sides. You pick your pill here, I don't care which one of them you do. You either do a conversion or you ln both sides. You can do an ln both sides and the base is all by herself, and that one is. So the left-hand side is simply going to be the ln of 1 600ths. And it's raised to the x. The right-hand side is the natural log of 4 1/10. Of course, you have to know your properties of logarithms to do this as well. And Maddie, I'm pretty sure you know what to do. Destiny, you know what to do with that x? That's okay, that's why I asked. You've got a property that says a logarithm with an exponent, put the exponent up front. So next we're going to shift it to the front. I know you knew how to do this last year, but that was last year. You slept since then. And I doubt you went home and used logarithms over the summer. I didn't. So anywho, remember what we have up there? We can turn that into the same thing. What understood symbol lies between x and that natural log of 1 600ths? Multiplication. The opposite of multiplication is division. Just divide that 1.06 out. Don't forget the ln like I almost did. Gone. There you go. If you do 12 and 14 before you do anything, you want the thing isolated. So make sure you, on 13 and 14, make sure you divide out those numbers first. I'm not going to do any more than that, but you have to have the base by itself. It has to be by itself. First step is always isolation. Alright, let's do 16 and maybe 17. So 16. Play the isolation game, kids. What's the easiest thing you can do on 16?
Make it a -5.
So you're going to subtract the 7. -3 e to the negative x is a -5. The next easy thing you can do?
Divide out the -4.
And don't worry about what it is. Quit being the kid who wants the decimal. It's 5/3. Problem with decimals is you'll do what with them? You'll round them. As soon as you round something, it's not going to be perfect. Alright, so we have two choices. We can ln both sides, or we can convert to logarithm. I don't care. Pick one. ln both sides. That's good, because that gets to remind us of something we're supposed to memorize. We have the natural log of e to the negative x equals the natural log of 5/3. I'm glad you remember that. Negative x natural logs of e is ln of 5/3. Now, Maddie, why did you say it was just negative x?
Well, because ln
ln of e is 1. Little note there, something you gotta memorize. Natural log of e is always 1. So if you just see an ln of e and it doesn't have an exponent, it's just sitting there, It's gone. Last move.
Divide up into.
So you'd say x is the negative natural log of 5/3. Now, if I wanted to be a tricky person, and sometimes I am, I would write that differently. I would. How do we break apart division?
Subtraction.
Fraction. And there's two things here. Parentheses matter. Negative natural log of 5 minus the natural log of 3. And what happens if you distribute your negative?
Works.
Well, what's the negative natural log of 3? No, it's the negative times the negative. Negative natural log of 3 minus the natural log of 5. A good standardized test would not stop at negative ln of 5/3. A real standardized test would have an answer that looks like that. I wouldn't dumb it down like they did for college algebra kids. That's what a real standardized test answer looks like. Because it's checking to see if you know all your properties. I said I do 17 too. What's the baby step on 17? Subtract the 4. I'm gonna make it 1. Next little bit we'll move. Right out 3. Natural log x minus 3 is a third. Think of your understood base. Remember, there's certain things in math that are understood to be there at all times. What's understood to be there? A little bit of e. Now, what's the technique here? Starts with an e, ends in an ing. Exponentiating. You're exponentiating, okay? If you have a logarithm and you want the answer, you do the reverse thing, what a logarithm is, which is the exponential form. So what's the base gonna be? That's right. E to the 1/3 is x minus 3. You're down to a one-step equation.
E to the 3rd plus 3. Oh.
Yeah, it's shifting. Ta-da! It's gotta be magic.
It's not negative, so.
You alright with that answer?
Yeah, I was just trying to make a fraction somehow.
Wouldn't be a pretty one.
No, I mean, like, I was trying to put it.
E is a rational number, there's not much you can do with it.
No, I was trying to do like E over 1 over E. I don't know where I was going with that.
I don't have a clue either. You might see somebody write it like this. That makes sense?
Yeah.
No, that's a legit thing somebody might do. We really need to choose one or the other on these. The extra space was for you to do your work. We really need to pick in math if we want to be about exponents or we want to be about radicals. We really do. Just going between the two throws kids off. Now, this says solve each equation by the method of your choice, and it says support your solution by a second method. I don't care if you support your solution or not. Just solve the blasted thing. That's all. So we have the natural log of x squared is 4. You could move the 2 out front. And you probably should. Because if you don't, you'll end up with an extraneous answer. Now, I'll show you what I mean by that. But you should move the 2 out front. So if you move the 2 out front, what can you do with it now? Divide it. And I'll give you the natural log of x is 2. Remember your understood? So e squared is x. It's done, just like that. Now, if you don't move it out, what you're going to have is you're going to have e to the 4th is x squared. Are you good on that? What's the opposite of squaring? And by default, you're probably going to want to put the plus or minus symbol in there. So you'd say it's plus or minus c squared. That's what you would say it is. Would it matter? I don't think it would. So this brings up a question. Should we be doing this, the first technique? Are we throwing an answer away? I don't think the calculator can handle exponents right. The old ones couldn't. Oh, it's only going to show you the positive one, isn't it? Good. All right. So, if you do it the other technique here, you just have to kind of think about don't be the negative. You see the justification by looking at the graph? Don't be the negative. It's extraneous. All right. What's scary about 29 through 31? Probably the fractions. That would be my guess.
I'll figure out which one I'm going to
Well, my guess is they're all a little scary. But they all have the same move. The same move. First move is clear fraction. So if we were going to do 30, what would I multiply everything by? 2. That would clear out the fraction. Just do both sides. And you'd have 2 to the x plus 2 to the negative x is a 6.
Don't they share bases?
Now what's the problem?
Don't they share bases?
They do, but they're being added together. So what you're thinking, I don't know, I'm not sure what you're thinking, but, so if I had told you this, 3 squared plus 3 cubed, is there anything you could do with that besides just figure out what they are and put them together?
No.
No, like you can't say it's 3 to the 5th, because it ain't. Is it?
No.
Okay, can't do anything about that. What could we do on this one? I bet it's going to start with an F. Let's look at it like this. 2 to the x plus 1 over 2 to the x. 6. See if that gains anywhere. May or may not. Everybody see the rewrite? Are we okay with the rewrite? Did it break any rules I've ever shown you? Probably not. No, it did not. Problem with it now is it looks like a fraction. How do you clear the fraction? Well, I multiply everything by it. Everything is going to get multiplied by 2 to the x. All 3 pieces. One of the things you got to ask yourself is what is 2 to the x times 2 to the x? It's not 2 to the x squared. So when you do x squared times x squared, what do you get? X to the 4th, right? If you do x squared times x cubed, what do you get? That was x. Go ahead. X to the 5th. What do you do with exponents? You add them. You don't multiply them. You add them. Like terms, you add exponents. So 2 to the x times 2 to the x is 2 to the 2x. Now, if you distribute to the middle, you got 2 to the x over 2 to the x, which ain't 0. There's a 1, okay. And the right hand side we'll just leave as 6 times 2 to the x. Do not think that is 12 to the x. Those 2 pieces can't be multiplied together because they're not the same base. This one's turning into a lot of fun, isn't it? Anybody got an idea for the next move? So aside from geometry, in every math course you take, you either have something on the left equal to something on the right, or you're equal to a what? A zero. That's it in algebra. You're either equal to something on the left and right, or equal to zero. Shoot that piece right there. You get that fugly looking thing. I wonder if I can still say fugly. I'm like banned from fugly too. Drew, can I still say fugly in the class? I don't think I can say it with your group. Alright. What good has any of that done me?
You can
It won't factor. I wish it would. It'd be cool if it did.
keep it, you can't quadratic.
You actually do the quadratic formula. Really, really weird here, but this is the quadratic formula. Because what you actually have here is you have something squared, something that's not, and then you have a constant. Yes, you actually do the quadratic formula. The real question is if I should make that a 4. I'm gonna write this, no, I'm gonna leave it for 2x. I'm gonna do what's called U substitution. I'm gonna let 2 to the x be what we call the letter U. I've never shown this to y'all because it wasn't in your standards last year. That makes this U squared. Because it wasn't 2x times 2x to the 2x. That makes this minus 6u and then plus a 1. Does it look like a quadratic now? So we sing a little song. This time it's about u, not x. U equals negative b. It doesn't sound the same, does it? Plus or minus square root b squared minus 4ac all over 2a.
Were you in the choir?
No, I was not. I just go to church.
Were you in the church choir?
No. I just go to church and I sing out the hymnal. Alright, so it looks funny, but it is what it is. B is going to be 6, negative 6, so it'll be 6 plus or minus square root of a negative 6 squared minus 4 times a, which is 1, times a 1, all over twice a 1. Remember, this is u, not x. It's u, not x. What's in the radical? 32. U is 6 plus or minus 4 root 2, both pieces over 2. Well, it is. You told me it was 32. 32, 16 times 2. Square 16 is 4, 4 root 2. And then there's some reduction. U is 3 plus or minus 2 root 2. But wait, there's more. That did not tell me what x was.
Nope.
That told me what u was. That is why I love this stuff. You go back to this stuff. 2 to the x is equal to 3 plus 2 root 2. This is all we're going to do. We're going to go ahead and finish this one. I'll probably do another one in class yesterday. 3 minus 2 root 2. If you're mad already, that's fine. You're allowed to be mad. It's okay. It's just math. I think I'd make that thing a logarithm. Over the basement. 2 over the argument, maybe.
Yeah, full plus
3 plus or 3 minus, right? Log base 2 of 3 plus 2 root 2 is an x, or log base 2 of 3 minus 2 root 2 is an x. And they're both actually going to be valid answers. I'm going to kind of skim over change of base here. Log base 2 of 3 plus 2 root 2 is the natural log of 3 plus 2 root 2. Sitting pretty over the natural log of 2. 4 decimal places, 2.5431. And on the other answer, you would just change that plus into a what? A minus. So those are a bit of a bear. And here's another answer. Negative 2.5431. Oh, no, they should be the same.
Plus or minus 2.5.
Yeah. So, absorb that. Think about that over Thanksgiving break. And on Thanksgiving, at least you're not doing logarithms, you have something to be thankful for. Anyway, that's where we're going to stop. Because I think Alice and Olivia need to see one of those done. And they'll probably, all of y'all will probably ask me the next day how to do the other one. Actually, you guys probably won't be here Tuesday. Tuesday's the UTM game.
I'll be here Tuesday.
You're not going to the UTM game? Then there's probably no point in coming to school. Oh yes, absenteeism.